Ladies and gentlemen, my name is Jozef Husar and I will present at the 6th AI International Conference Management of Manufacturing season the article Optimization of the Production Process of Defect Identification in the Production of Face Shield using Fused Deposition Modeling Technology. At the first, we need to say something about types of additive production. At present, there is a wide range of additive technologies. The differences are mainly in the way in which the individual layers of the model are applied, and the range of usable materials used for object creation. Choosing the most suitable additive production process for a particular application is very difficult. For your needs, the material extrusion method was chosen, specifically FDM, Fused Deposition Modeling. This technology uses direct application of the material by melting in the print heat, extruding it after it reaches required temperature, and afterwards it creates the desired model layer by layer. The most common materials are thermoplastic. FDM technology is also the most widespread form of 3D printing. At the same time, it is the less economically demanding 3D printing technology. The disadvantage of this technology are the long printing time and printing quality. At the first step is 3D printing is convert the CAD model to a G-code format requires for the 3D printer. The program contains the coordinates according to which the nozzle moves, print and extrusion speed, and other operation parameters required for successful model creation. FDM printing is based on the principle of melting materials that is the form of a plastic string, a filament. The filament is wound on a spool from which it is unwound required. The print heat when prints the physical 3D model layer by layer according to the digital model. The molten material is extruded through a nozzle onto a production platform where it cooled by active fans, and after the subsequent solidification, the final model is created. The parameters and cause and printing errors using FDM technology. At the first is the printing surface, layer adhesion and layer thickness. The surface must be perfectly flat for the most accurate print possible. The adhesion of the layer depends on several factors such as the printing speed, the type of materials, the printing temperature and nozzle diameter of the height of the layer. Next parameter is layer thickness, which FDM printing it is possible to see different layer height, the layer height of 50 to 800 microns in use. Next parameter is nozzle diameter, variable from 0.2 mm to 3 mm based on the used filament diameter. The diameter of the nozzle directly affects the width of the extrusion. While printing, it is necessary to monitor that the extruder dispenses from correct amount of filament. This process has significant meaning for dimension accuracy of created model and print quality. Next parameter is printing speed. Visually, a slower print speed supports a higher quality results, although the time saved of the higher speed may be authoritative for some manufacturers. It is safe to say that lower print speed are required for high quality production. Next parameter is nozzle temperature. Temperature affect the visual result and the mechanical properties of print. The types of materials used is important. Next parameter is infill pattern and infill percentage and number of outer perimeters to bottom layers. SARS-CoV-19 is severe acute respiratory syndrome coronavirus 2. It is the same given to the new coronavirus in 2019. COVID-19 is the name of disease associated with the virus. SARS-CoV-2 is a new strain of coronavirus that has not been previously identified in humans. On the basis of the European Centre for Disease Prevention and Control has established basic preventive recommendations in the fight against COVID-19. Do not touch your face. The virus can enter your body and out your eyes, nose and your mouth. So it is important that you do not touch your face with unwashed hand. Wash your hand. Frequent washing of your hand with soap and water at the last 20 seconds is thorough cleaning of hand with alcohol-based solution, gels of tissues is recommended in all settings. Stay away from infected people. Avoid close contact with people infected with COVID-19. Avoid social gathering. Avoid physical gathering events and other social gathering in areas of ongoing community transmission, and follow your local recommendation for mass gathering. Using the face mask. Wear the face mask indoors and outdoors whenever a physical distance from other people cannot be guaranteed. Methodology. Due to already mentioned 2 types of 3D printer were used for the printing of shapes shields, namely Creality Ender 3 Pro and Creality CR10 Max. These are SIM PLA FDM printers that are affordable. PETG plastic mladej filaments was used at the materials for the printing of shaped fields. It is a strong and tough material which is characterized by good temperature stability. This material is sustainable for printing large objects due to its small shrinkage during printing. Unlike other materials, PETG is more resistant to acid and solvents, high and low temperatures. It is possible to thermoform and object extruded from it or to polish and with heat. The material was chosen because of its properties and especially its relative flexibility and resistance to higher temperatures. Face shield used by healthcare professionals and first contact people are often used for several hours. Therefore, they must be disinfected in or heat sterilized to prevent the transmission of virus. As mentioned in the introduction, our aim was to choose among the large number of 3D models of face shields that best meets the condition of rapid production. The design of face shields consists of protective frame, protective foil, reinforcement, 2 crack nuts and screws, 1 cover fold unit. As part of the preparation of the G-code, all the components necessary for the production of one face shield were placed on the printing pad. Thus, the optimization process was implemented for 3 components. During the process of printing face shields, we encountered a number of problems, specifically the adhesion of surface when was the shrinkage of materials and subsequent detachment. Also, for the first piece, the problem was a long printing time. We tried to remove this by changing the initial layers speed and the initial layers height. Proper way of calling over its absence also played on one of the key tasks in this chase. When we come to results, I will say something. It is well known that the design quality of commercially available FDM device is often debatable. Those device-specific settings often consist a unique modification that may not apply to every design. However, This article presents a software solution and error analysis during the optimization of these processes, which are characteristic of a specific case of efforts of rapidly produced thin wallet components. If we want to evaluate the overall shortcomings that we announced during the printing of shape shields, it is necessary to choose the right method. The most sustainable method is the cause and effect diagram, also called the Ishikawa diagram. Diagram cause and effect was processed for FDM condition of shape fields printing. Figure shows us the individual errors we announced during components printing. As for the printing of plastic nut covers for screws, their production was seamless, their composition is solid, so the chosen materials is ideal for their production. As can be seen from the figure, most of the shortcoming accuracy mainly of the frame of the face shield. The reason is mentioned in thin wallet design. At the end, I will say something about conclusion. In the first wave of the fight against COVID, our company for several months with a great shortage of protective equipment used not only to protect your country population, but also to protect workers in the medical, social and other spheres. Unknown, many manufacturing companies required their operation of the product focus of production of this protective equipment. It was difficult to initiate phase to ensure that the necessary materials was available to all. Therefore, many young people who had 3D printers took this task. The faculty teams also took parts of production over 1,000 face shield on the premises on the Faculty of Manufacturing Technology of Technical University of Kosice established in Presov. Since the operating stage of the first wave, latest 4 months, many improvements were made. Therefore, in this article, we have sought to analyze the shortcoming identified during the period using in a cause and effect diagram. Also, on the basis of the analysis process of 3D printing and assembly, it was possible to shorten from the original 4 hours to final time something around 1 hour. As a result, the overall model before the after optimization changing minimally, but our user-centric requirements were maintained without changing the technical characteristic. As a main advantage of optimization, we consider that the total time has been reduced 4 times and alpha error has been eliminated, and this fall allowed us to procedure longer numbers of the face shield and help more people in the first line. Thank you for your attention.